So there we go. Good morning, ladies and gentlemen. Again, thank you for joining this fourth session in the Zero-OS EAP program, the Early Adopters Program. As announced in the discussion group, in the Telegram group, this will be like a session that is rather like a preparation to the next session. And I will be open with you. Reason for that is that, well, several reasons. Is that because I have been preparing, of course, this session from a technical perspective, trying to set up the orchestrator, setting up the cluster, which is all working fine, but not on my Mac. So I lost a lot of time with that, and that part is not ready. Another reason, as I said the other time, is that many of the people that typically attend the session this week from Egypt could not attend this week. So anyhow, we planned to do a repeat session next week. Next week, as I will discuss again later, is only one session that we will do. That's a session on Monday. And then we'll come back to you the week after with again 2 sessions per week. Now today is a special session also because I have a special guest, that is Christophe, whom I will introduce to you in a minute. Christophe is a part of the engineering team. Well, he's actually leading a lot of the products we are building, so he knows a lot more about what we are doing than I do. So it's also a perfect occasion for some of you to ask questions if you want to. And he will be demonstrating the orchestrator, and that's actually what we will then be setting up. So the session today is basically not about setting up, but it's about demonstrating the use of a Zero-OS cluster and playing with the orchestrator. Which is just as we had with Zero-OS Node. It is exposing a RESTful API. The difference, of course, this time is that the RESTful API that is being exposed by the orchestrator allows you to interact with the Zero-OS cluster as if it was one single thing, as if it was one big computer. While it is, at the end of the day, a cluster, a pool, basically, a resource pool of multiple Zero-OSs, which are in some way connected very closely or very distributed connected. So that is what we will be discussing today with you. Good. Now, first of all, what will be covered today, first of all, I'll again go over much more quickly than the previous time over the session schedule so that you understand where we are and where we go and what the next session will be. We have a few follow-up points, and then most probably I'll switch as soon as possible to the demo with the orchestrator, because that's what you will appreciate most in today's session. But I also need to, partly because of the follow-up we need to do and the questions I got after the session, I'll also discuss jump scale, and I'll discuss at your service a little bit more, because as you will see, as part of everything we'll do today with the orchestrator and also the way we will have to set it up, it's important that you start to understand a little bit more about what at your service is and what jump scale is. Until now, we haven't been providing any definition about this, and I think it's the best moment to do actually that. So exactly where we are today, as you see, we are July the 20th. It's Thursday today, and the session. Well, let me immediately correct it. It's not about setting up, but demonstrating. It's a demonstrating demo of a Zero-OS cluster and playing with orchestrator's APIs. And I guess for most of you, and actually certainly for myself, this is where it really become really cool and exciting, because then we are really interacting with the pool of multiple Zero-OS nodes, and you are starting to get things done. Already before, it started to become really nice, because you could create containers, you could create basically images, lists or F-lists as we call them, in order to boot containers. But once you go to the next level, and once you start to work with the cluster, you could actually do the exact same thing, basically deploy a container. But when you do so, in the context of a cluster, at the end of the day, you don't really care too much about on which node, at the end of the day, your workload, the container, will be deployed. It will be deployed somewhere in the cluster. And we are also getting closer and closer to one of the other discussion points, that as part of the actual deployment and basically the life cycle of your workload, the full life cycle of your workload, it all starts, of course, with the provisioning and deployment. Yeah? But it's here that also at your service comes into play, because once you start deploying a workload in a cluster, you say, like, I'm talking to the orchestrator, like, okay, have this deployed for me. But also there, typically the at your service engine will take over and make sure that whatever you deploy is also getting monitored. So that, for instance, imagine that one of your workloads goes down on one of your nodes. You should not even know which node goes down. That in somewhere or another, that indeed at your service is seeing that and is making sure that your workload comes up again on another node, and that from the bigger perspective, the users, for instance, and from the perspective you interacting with the orchestrator API, it's just there, your workload. So all that will not be demonstrated today, but it's thanks to introducing a cluster, it's thanks to introducing at your service and the orchestrator, that you start to have this really self-healing environment where you can really trust your workloads to run perfectly, not just at provisioning time, but also once it got deployed. That's where things become sophisticated and ready for real workloads. So that's why it's important, this session. So this session is a demo, it's an introduction. I've also prepared already some little slides to make it more clear. Next week is really about making sure that you can do a deployment yourself. So typically what you would do is, well, as you did already today, or must have done today, or are planning to do probably this weekend, you deploy at least one Zero-OS node. What of course you could do then is deploy a next one and a next one. You could deploy all of them, why not, in a virtual box, or you could deploy one in KMU, another one in one in a virtual box, and yet another, I don't know, somewhere else, virtually in the cloud. And you could stick them together, and that's then the next session, stick them together as one cluster. And even while they are really distributed all over the place, you can treat them as one thing, and that's what you will be able to do during the next session. I will make sure that you understand how to do that. Yeah. Based on that, it becomes more and more sophisticated, because the next thing after containers then is working with virtual machines. And as all of you know, virtual machines require block devices. And at some point in time, even a container clearly also will need block devices, basically, for instance, to persist states. Sometimes you really want to persist state, and that's where certainly also block devices become very useful to use. In order to have block devices, you need block storage interface. And as you will see, we will introduce block storage, and I have prepared already a nice slide about that. Block storage as a set of containers. So in a way, block storage is being added into a cluster by deploying a bunch of containers that is implementing basically that functionality. It's just an example of a workload that is basically adding functionality to your cluster, and in this case then block storage, enabling you to start virtual machines both directly on top of a zero node, so you could then start using the Python client I introduced already to you earlier, to start a virtual machine on a node directly by interacting with a specific node. And because you have then block storage somewhere in the cluster, you can then leverage that specifically on that node. But of course, it becomes more interesting if you say to the orchestrator, well, here it is. This is my virtual machine. Get it deployed in the cluster and use also the block storage provided by the same cluster. So that will be then the session that follows on that. And I'm not going to elaborate on all next sessions, but all next sessions basically built on top of that. Then you have OpenV Cloud, which is basically another layer on top of that. Then you have indeed the concept of blueprints that allows you to deploy and provision things even more easily without having to interact with any API. It's about creating blueprints. And the last session is about creating basically the templates that you need in order for the blueprints to work and in order for at your service to do the real self-healing work. So that's where it becomes really, really interesting. Good. Now, some follow-up points. I don't have much. Again, the prize for most interaction goes to you, Arne. As always, you have been very active in talking with me, challenging me, asking excellent questions. I love it. I love you guys. I love you all guys, of course, but I love the interaction with Arne a lot. Arne, as I said already the previous time, is already running Zero-OS on Hyper-V. Arne is also the guy who told me he got the JumpScale 9 Docker container up and running on his Windows machine. He faced some problems, and we are there to support him, of course, because I ask all of you to do exactly the same thing and indeed deploy JumpScale 9 from build 903. But Arno was the very first to discover that 903 doesn't work, not just only on Windows, but in the meantime, I have the same issue on Mac. That is being solved as we talk. So don't borrow too much. So remember already today, if you are going to deploy indeed JumpScale 9, you rather want to use the master build for that. And again, we have slides for that. This is this slide deck. Yeah? So set up your JumpScale 9 Docker container, and instead of specifying export gig branch 903, which is what is supposed to work, you need to do it like this and specify master. That's very important. And also very important, a colleague of mine, Wijnand, lost a lot of time by using my instructions where I specify this export here, specifying the gig diff. This clearly only works on Linux. When you do it on Mac, you need to specify it like this. It was already in documentation, but I forgot to put it on the slides. And probably for Windows, whatever, make sure that you put here an existing directory. That's important. Yeah. So this is something that you will need. I will tell you already upfront why. And I'll come back to another follow-up question I got from Arne, which is quite important to answer. The why answer is simple. When we deploy an orchestrator, and as you can already probably tell, the orchestrator is, as the word says, is the orchestrator of a cluster. In the current phase, we typically recommend deploying this orchestrator into this JumpScale 9 Docker container. So basically running on your physical machine, you have this JumpScale 9 container running, and into that JumpScale 9 container, we install then the orchestrator. So you need basically the JumpScale 9 container to do so. That's why. Yeah. Now, the follow-up question, and I think I started to create a slide for that I didn't finish, but it is somewhere here. The question I got from Arne is a very good question. But why? But really, why are you running this jump scale thing in a Docker container, and why not just run it in Zero-OS, in a Zero-OS container? That's basically the question I got from somebody. Okay, Mark, you are asking question. Let me check. Would you not be able to use the title to specify the home directory? Yes. Would you not be able to use the tilt? Yeah, you could specify anything there, Mark. So I got a question from Mark on this one here. So you can clearly use the tilt here. That will perfectly work. So don't panic there. So you can specify any directory you want there. That's the point. Now the question of Arne is an excellent question that I wanted to answer. Can't we just deploy the Docker, well, the container on Zero-OS, because at the end of the day, it's just a container, and why not deploy it as a Zero-OS container on a Zero-OS? And the answer is on the slide, of course, you can do so. It's perfectly possible. And you basically use the instructions that I gave you during the last session. There is even a Docker function to export the content of a Docker container into a tar file, and then you simply upload that tar file to the Zero-OS hub, and there you have it. You have your flist available from the hub, and you can start a container running indeed that jump scale. And yes, from there you could even add the orchestrator, as we were demonstrating to you. That's all very possible, and please feel invited to do so. The reason why we are not doing that, well, it's quite straightforward. Simply because, well, it's a bit chicken and egg, of course, but that argument doesn't stand long, or anymore even today, I'd even say, because it is there, you can use it. But the real reason is that the developers creating all this, they rather prefer working on their local machine, and they develop and they debug, and doing that on their local machine. Currently doing that with Docker is a very straightforward and easy way to do so. If they would want to do this exact same thing to a container running on Zero-OS, they would need to use, for instance, their QEMU and have a virtual machine running Zero-OS, and then in that virtual machine they would have to run the container, which is quite possible, but today they are not doing it like that. That's the only reason. So, but then again, it's purely a matter of priorities and focus, and most importantly, to make sure that we can support you the best possible way. And at the end of the day, we are a startup. We have limited resources. I certainly have the full support from the development team to support you, but you understand very well that we rather define today very clearly how we work, how the developers work today, and we rather want you to use the same, let's say, container currently running on Docker to support you. And then step by step, we will make sure that we can support you on other things. That's the reason. Now, other follow-up points. What I did, so the Hyper-V documentation is being created thanks to Arne. I will include it in the slides and in the documentation for sure. It comes, so don't panic there. It will come. On the topic of abbreviations, what I already did is a little bit more than the other time. So on the abbreviations, we'll discuss at your service in a moment. We discussed already the other time RDB. To be honest, I don't know what RDB stands for, what the abbreviation exactly means. That's not that important today. Just remember, and it'll come up more and more, that RDB is what we use currently. It will certainly change, but remember already today, that's what we use today. RDB is an open source project on GitHub. There you have it, the URL. It's basically a Redis protocol compatible NoSQL storage interface. That's a long thing to explain. It says two things. First of all, it says that it's a way of interacting with storage through Redis, yeah, and Redis is what many people use as let's say a key value store in memory that allows you to share data structures in memory and share it among processes, and even more importantly, to share data or data structures among processes running on several physical and virtual machines. So this is actually what we use and what many people use in the open source community for sharing data structures among processes that are distributedly working together. Now, it's a very powerful way of working, and we are very experienced in interacting with such a key value store, let's say. We use it also a lot for message queuing. For instance, you might remember in my first session, when you interact with Zero-OS, for instance, you interact through the Core Zero or Zero Core, which is basically the system D replacement that is part of a Zero-OS operating system. It's basically the master process of Zero-OS. Interacting with that component of Zero-OS is done through Redis, where Redis is being used basically as a message broker on a specific port. Now, RDB is basically a Redis front end for a NoSQL storage backend. The NoSQL storage backend we use currently is RocketDB. And RocketDB, that's what I introduced to you the last time. Maybe I should also add it here for follow-up later, that I specify about RocketDB. It's not really an abbreviation, but I'll come back on it. RocketDB, remember, is what we use, for instance, for two things currently. We use it both for the F lists. So remember, this is this small file that contains the pointers to the actual data that is being stored in the backend, and that's basically the format we use for starting the Zero file system. So starting containers, and well, it's a database. It's a NoSQL database, and we use it as the backend also for, as you will understand in a minute, for the block storage and the hub. So both the way we implement block storage in the backend, the actual data goes to RDB, so the Redis protocol, and we use currently RocketDB in the backend to store the stuff. Both for the F lists, as you will see, the actual data I mean, and also for well, the way we do it for block storage in general. We'll come back on that. And NBD, as we explained the other time, is abbreviation for network block device. It's basically a protocol. It's a well-defined protocol that we implement. With the whole block storage solution, and that's implemented in our case in one of our repositories. That I will point you to again, GitHub Zero-OS, remember, and there we have the zero disk. Yeah? This is basically where we implement this thing. Right? Well, so that's we'll come back on it during the next session, and more importantly during this session where we start to talk about block storage, and I'll also show it to you on the slides to introduce the demo of Christoph. Okay, Let me introduce a little bit to JumpScale and at your service, just by two definitions, nothing more, just so that you understand. High level at your service, as a definition, is an application lifecycle management system for cloud infrastructure, so for both cloud infrastructure and application workloads. So let me clarify a little bit what I mean here with an application lifecycle management system. The point that I try to make here is that at your service is more than just a way for provisioning or for installing stuff. Most of the time when we show it to you today, we show it to you also as being part of the deployment mechanism of the orchestrator or the cluster. We show it to you as a way to deploy something, as a way to do the actual provisioning of, in this case, the setup of a cluster, the setup of an orchestrator, the setup of a storage pool, the setup of the block storage on a cluster. We always used in the backend at your service for that. But in reality, it's more than the thing that you use for the setup. It's there to support you in the full life cycle. And most importantly, when I say full life cycle, I mean it's this thing that also can monitor your workloads, not just your workload, but also the actual cloud infrastructure. So we also use it to do it, to deploy the stuff that is basically hosting your application workloads. And as you know from the schedule, we'll have a full session on how you can create your own at your service templates so that the at your service engine becomes intelligent and becomes clever about how to do the self-healing. And when I say self-healing, I mean more than just the provision. It's about auto-scaling, about an auto-healing of applications. Huh? So at your service is actually that. Now, at your service, the core component of at your service is an at your service server. And as you will see it in one of my slides, that's one of the components we will deploy as part of a cluster. Huh? The other component is the orchestrator. And basically the orchestrator and the at your service server work together to do the actual provisioning, but also to do the full lifecycle management. So that's what you need to know. Huh? Next, at your service is basically part of JumpScale. And JumpScale is in a way what this company has been building during the last 10, 15 years. Is basically the product we also sold many years already ago under another name to Sun Microsystems. So it's basically a set of extensible APIs, very targeted to Python programmers. So it's an extensible and easy to use open source cloud automation framework. Basically, it's a comprehensive API library for doing a lot of stuff. Basically, it's something that we built over time to make our own life easier. I couldn't explain it better. From a data center perspective, you typically have a lot of system operations to do, a full wide range of system operations, from formatting disks, from whatever, doing better FS stuff, from whatever, from deploying stuff, from even installing a Go compiler or installing portal software, whatever you typically need to do in order to provision and to interact and to monitor and to manage basically every single component in a data center. You could do it at a command line, but at some point in time, from a Python programmer, you really want to automate that, and you really want to create software for that. So meaning you need to build up a comprehensive API library for doing actually that. And that is what JumpScale is. And JumpScale is of course also open source and fully available on GitHub. As you will see, JumpScale provides a lot of repositories. I'm not going to discuss all of them. One of them is this developer one. that I typically always point to when I say that I love you to create a Docker container running Jumpscale 9. And basically the documentation, the core documentation for setting up such a Docker container is here actually on this page. So you will recognize that. What you also see is that in the Jumpscale developer repository, I started to create some documentation. Yeah, and the documentation that you will want to check is not on the master branch, but is on the 903 branch. So remember that. And I'm a little bit concerned because I see that my stuff is not here anymore. So something changed here. Well, sorry, I'm not correct. What I mean, my documentation is rather in the repository at your service 9. That's what I mean. There you go to again docs, and there you go to, for instance, the getting started. And in the getting started, I typically point you then to the create a Jumpscale 9 Docker container. That's this one. And here you see then again this documentation. I always copy paste to the slides, so that's what you will find here. It's also there that I have other examples of things that you will want to do. It's like start at your service, join the zero-tier network, install the Python client, start an at your service portal, things that I will introduce to you later. And then it's not the topic of today, it's the topic of one of the later sessions. I'll then point you to all kinds of documentation that you will find here on how to use at your service to interact with the system. But that's the topic for later. Good. Now back to the slides. So Jumpscale is this big library providing you all this nice stuff, and at your service is part of that. At your service that I just discussed as part of the slide deck is part of that, and that's how I want to introduce to you. Now, as an introduction to the demo, what I've done, well, very simple. Let me maybe take my other browser screen for that, because I'm still preparing that slide, but you'll see it. Not this one. Let me show you. Let me show you as an introduction to the slides. So what I will make it a little bit bigger because I remember that people have problems seeing it on my screen. So today what you have is this. So just a bunch of Zero-OS nodes. Some of you have been creating already one, some of you have been creating already 2 or more Zero-OS nodes. And as I said, it's basically perfectly possible that you deploy one on Azure, one on Amazon, you deploy one on QEMU, you deploy another one on virtual, on any virtual machine, on VirtualBox. And like that, you could really deploy multiple Zero-OS nodes. And they are not related at all. They start to be related when you add them to what we call the zero-tier management network. And it's a very important point that I use the word management in this context, because that's where we use the zero-tier network functionality for. If you join them in this network, the purpose of doing so is that you will do the management of the nodes through that management network, which can of course be nicely secured. Until now we haven't, well, secured at least already by the fact that you need to know, remember the zero-tier network ID, and if somebody wants to join that zero-tier network, they need to request to join. And remember in my previous slide, somebody needs to accept the request. So that's how it works. But of course, what I didn't explain you yet, and that will certainly also be topic of next session where we show you how to set up a real cluster, you need another level of security. And this other level of security is not by just having a zero-tier management network, but is by making sure that whenever you try to interact directly with Zero-OS nodes, which you typically will block, And especially if you start to interact with the cluster through the orchestrator, you need another level of security. And that's where we will introduce you to itsU.online. Yeah? As you will see, we require you to send along a JSON web token. And if you are not able to send along the JSON web token that you got from itsU.online, you will not be able to interact with the Python client, or you will not be able to interact basically with the orchestrator API. So there are several levels of security. And by the way, thank you again, Marne. You were the first to ask me about this. You take me again on speed, and yes, we will introduce that to you later. But for now, the first thing that binds multiple nodes is a zero-tier management network that I introduced to you the last time. What we will do today, well, we will not do it today. We will show today how you can interact with it. But what we'll do next week, we'll show you how you then do the next thing. How you basically add to this zero-tier network two things: the orchestrator and the at your service server. Now remember, you could perfectly take one of the nodes and install the orchestrator in a container of one of your nodes. That would perfectly be possible. And even more, going forward, clearly that will be the way you will set it up. You will have some Zero-OS running somewhere, and this Zero-OS typically would not be actively be part, or could be part of the resource pool you're creating with this cluster. The point I'm trying to make, it could run anywhere, but the point is that this orchestrator then typically runs on Zero-OS. In our setup, it runs basically on your local machine in a Docker container. And then the at your service server typically runs in the same Docker container. You remember in what I just showed you, the documentation here, this documentation I showed you in the at your service 9 documentation. I need to share this link too. In the getting started, that I say that you have to go through several steps. One of the steps is create a JumpScale 9 Docker container. So that's what I've been inviting you to do already multiple times in my slide. The next step is to start at your service. That's what you will learn in the setup in the next week, but you could already check the documentation how to do that. The next step is then typically to join the zero-tier network so that you can interact with the at your service engine, because also at your service, remember the core component of at your service is an at your service server, and also that thing is exposing its functionality to the RESTful API. In order to talk to it, you need a zero-tier network. What I will add to this documentation is how can you then secure this RESTful API endpoint with not just by that you need access to the zero-tier network, but by next level of security, by making sure that it's protected by itsU.online. That's what I will add by next week in this thing. And then you can really go through all these steps that will support you for doing actually what we want to achieve. Now, what we will not do today and not do next week, but it becomes more interesting when we go to the next level. What is the next level? The next level is then, okay, we have our orchestrator, and we will show you today that through interacting with orchestrator, you can create a container, just as we did last week, but this time we do it through the orchestrator. And what we do then, well, one of the workloads that you will want to put on the Zero-OS is a storage cluster. And let me be very clear here. I'm not talking about a block storage. I'm talking about storage cluster, tout court, just storage cluster. And basically there you see it, we come back to these concepts of RDB. And basically what we will do when we deploy a storage cluster, we deploy a bunch of RDB containers. And what I try to visualize here is that you typically deploy on one Zero-OS node multiple, here I visualize 3, it could be more, it could be less, RDB containers. And remember already today, we will discuss this at length in the later sessions, But remember already today that you typically deploy one RDB container per physical storage device. Or remember the second session, per storage pool. So if you have, for instance, a Zero-OS node with 3 data disks, SSD data disks, for instance, you could pull them together as one single RAID 0 pool, and then you would have one RDB container linked to that pool. Or you could decide, no, I'm going to link one RDB container per SSD device. And that's what will typically happen in the reality in the typical setups we do. We will not pool them, we will have an RDB container per device. So per SSD, we will typically have one RDB container. And remember what I introduced to you in my abbreviation slides. That means that in the backend, per SSD, we will typically have one RocketDB, and through the RDB container, you have a Redis interface on top of that. That's what will actually happen, and that's what we deploy. And what we do then, we do the same thing on the second, the third. We visualize here that we only do it on 2 nodes, and there is some configuration that allows you to say that these RDB containers are like clustered, that they know of each other, and that you can talk to them as being a cluster. And that's what we mean with storage cluster. And here you see one based on SSD. Yeah. Now done, once you have that, the next step is, in order then to have virtual machines to be able to start, remember you need block storage. And block storage is being supported by the implementation of an NBD server. And remember my introduction to NBD. NBD stands for Network Block Device. It's the name of a protocol, and we implement that protocol in another container we call the NBD container. It's basically an NBD server container, or a container implementing the NBD protocol as part of an NBD server. Now, the logic is that you have per virtual machine, you have a choice there, that you per virtual machine, you have one NBD container supporting all virtual disks of that virtual machine. There is also the option that you have one NBD container per virtual disk in a VM. So if you have a VM with a boot disk and then like 2 additional data disks, one for instance, running a SQL server, and yet another for running whatever, some temp data, for each type of storage, we will typically provide another kind of container. So just remember already that. Huh? Now, the point that I try to make here is, this slide, what it shows you is that you have a second layer. So after having introduced the concept of storage clusters, the next level you typically need in order to support block storage is NBD containers, yeah? that talk to this cluster. Now, in reality, it's a little bit more sophisticated. Let me show you. In reality, you need more. And I'm not going to discuss this at length today, but be prepared that you will understand that very clearly going forward. You also need a T-log container. A T-log container is basically a container implementing yet another workload, yet another functionality through what we call the T-log server. And a T-log server is what you typically need to persist, remember state, to persist basically whatever you do in the backend, and to make sure that whatever you store is being distributedly, is stored distributed. First of all, you need this T-log container so that you can work with a backup storage cluster that is basically just as the very first storage cluster, a backup to the first storage cluster, so that you have high availability. That's the first thing at SSD level. And then we implement another storage cluster on HDD, real physical cheap, common, nothing special hard disks, where we will use all kinds of pressure coating techniques to make sure that your data is persisted in a very scalable and a very distributed and fast way over your cluster, which is typically containing more than just these few nodes. So this is typically a full setup of everything you need to start supporting virtual machines, or to start supporting block storage, or to start implementing a block storage layer on top of a cluster. There is one extra thing to finish then that you need to make it really work, and that's another network level. Because you don't really need it. I mean, technically, and that's certainly what you will be doing as part of all the labs for your own setup, you will not do this last step, but this last step is adding two things. Is first of all adding a management network, a backend management network, a 1 gigabit Ethernet management network, this big blue thing that basically provides the same functionality of the Zero-OS cluster, well, zero-tier management network, but it's really a backend one, which is of course much faster. But most importantly, what it also adds to typically yet another switch. So for the first one, you typically have a management switch, a physical management switch you install close to the nodes. And then you have another high-performant management switch that allows you to have a backplane network. It's basically a management network, a backplane management network for the storage layer. And that's important because in order to have a performant block storage backend, you need, of course, a network between the nodes which is really, really fast. And that's this is a typical setup of what you would do in a data center, where you would really take, like in this case, 5 Zero-OS nodes. You connect them nicely together to a very solid, sound backend network next to the zero-tier management network. And this would be a full setup of something you would be installing in a physical data center. But I repeat, this is certainly not a requirement. By design, Zero-OS is something to deploy in a very, very distributed way. And the setup you see here on the screen would be one of the let's say, one of the installations that is being made available into a bigger installation. This part of an installation would then be like a very performing backend that typically is being used by a commercial customer that has some very specific workloads, that have some very specific SLA requirements and performance requirements. That's what you would be using for. But then still again, and that's where the beauty really starts to come, people that own this setup could then still decide, you know what, 20% of my capacity provided by this backend, I make available through the orchestrator for others to use. And we'll discuss that later. There we need to talk about blockchain mechanisms, where we allow you to earn money with your setup so that people can use your capacity and you get paid for it. For instance, so that they can use CPU power and use whatever you provide from your cluster in the backend. And you basically, like a solar panel, you know, you have a solar panel you use for your own usage, your own needs, and the spare capacity, like you can specify like 10% of my spare capacity, I make available into a larger grid, a larger cluster, so that people that need extra capacity than what is being provided by their own cluster can use it. So that's where you're going to. Okay, I've been talking a lot again. Christophe, I know you are ready, and you are probably not fully ready, but I think people really want to see something now. They have hear me talking too much. They don't say it to me, but I can feel that that they are thinking that, and they are of course right. So Christophe, I will stop sharing my screen, and I'll invite you to take over the screen and show them the orchestrator, because that's where it becomes really exciting.
Can you hear me now, like this? Or because I'm using your sound now?
You are using what?
Yeah, because otherwise it just...
Okay.
Echo.
Well, for me it's okay. Do you hear Christophe, or is it not really clear? Maybe I should take another microphone. Let's take the microphone of my system, which is better, the built-in microphone. Could you confirm that you hear Christophe talking? Christophe, could you say something?
Hello, guys.
You hear Christophe?
The other mic was better.
Was the other microphone better? Okay. Also, when Christophe is talking, Christophe, can you talk again?
Yes, yep. Hello,
Okay, but I take the other one now. Okay. And you know what? Let's do it like this. That's better. You see Christophe now?
Yes.
Yeah. Okay.
Yeah, okay, so, well, I will just start from introducing a bit the Orchestrator API and how we build these APIs and how we also document them, because that's also work that we did regarding all the APIs that we are going to produce, is trying to have something which is unified and that you can always feel, well, once you know how one API works, you could expect the same behavior for the others. So basically the page that you see here now,
we all see the screen of Christophe, just to be sure.
Yes, yes.
Yes.
Working.
So basically what you see here is an HTML page that it's basically the documentation of the API. So you have all the endpoints of the API, and if you click on them, you can inspect and see exactly what you need to send as a request, what security and authorization is expected for that method, and also the response that you are supposed to get. Of course, this includes the description of all the type and stuff like that. This page is basically generated from, let me show you directly, from a RAML file. RAML is a language which is used to describe REST API, and it looks like this. So basically, it's just a text representation of all your types and all the methods that your API is composed of. And we use this as a mean to have something really easy for people to inspect and investigate. So basically, as soon as you start using our APIs, you just need to refer to that specification, and you have all the information that you need to know to use the API. On top of that, we've also created a tool, a pretty cool tool, which is called GoRAML, which basically allow us to generate server code and client code for these APIs. So basically, all the server that we generate are created from like the same generated code, so they behave the same more or less. And the client, it's basically out of the box. You just give him the spec, the RAML spec, and yeah, it outputs you a client which is ready to use out of the box directly. So far, we support 2 or 3 languages, Python, Golang, and Nim, for the generation of the clients. And of course, there is more to come. So that's also really nice if you have different language that you want to consume the API from. Well, you just need to maybe create an issue on GoRAML if you have a language which is not supported. And you could have the Python client or any client generated out of the box. So it's also easy for you when we do an update on the API to maintain your client up to date, which is basically just one generation away of the new version. Yeah, so that's about it, how we create the APIs. So about really the orchestrator API, which is basically, I think you've seen, you have session with the Zero-OS client, which is basically that, well, from IPython directly talking to a Zero-OS node.
Yes.
This API is basically, well, a superset of that, that allows you to have a REST interface on top of this client. So you will find, like you see, a lot of methods that you've already seen in the Zero-OS client. So like listing all the nodes, the jobs pinging, inspected the disk. Then you have all, this section is regarding the management of your disk, storage pool, and file system on top of them. You have the zero-tier network, everything related to gateway. That's probably something not been introduced to yet.
No.
And then what we are going to play with today is basically the containers, how to can create containers, list all the containers on a node. And the last part is probably for the next session when we, like everything related to VMs. The last two is basically storage cluster that Yves introduced a bit earlier today. vDisk is also something that is used for virtual machines. Well, so I think let's start directly and let's try to start using it. So I'm using Insomnia, which is basically just like a nice HTTP client. So you have something a bit visual and you are not just in the console. Well, usually what I do when I end up on an orchestrator, I start by listing the node. So I'm just going to like, execute the request. So with,
Okay.
see. So here, basically, that's the response that you receive. And here we see that we have like a bunch of nodes running that are attached to this management network. If you want to, like, for example, here on the nodes, this is the call I just did. So it's basically calling /nodes, and this is listing all the nodes of your grid.
And by the way, see the security there.
Yeah, indeed. Yeah, that's basically the introduction in the last release that we created. The introduction of basically all the security around the orchestrator and the full flow from the orchestrator to the nodes. So you see, basically, you see that what you expect to receive when you do this call is a list of nodes, and you have a description. Yeah, so basically, and then it describes also what a node is, the type node. You expect an ID, an IP address, the status, and a host name. And you see that, yeah, effectively, that's exactly what you get. So now let's pick a node. We have just this one. I'm just going to configure it. Node ID. That's probably already set up. Let's pick just another one. Up. And then I can just ask the detail about this node. Wrong address. Yes. So now what's happening, it's basically the orchestrator is asking at your service, okay, give me the detail about this specific node, and it returns you the same information. So now let's try to create a container, right? Because that's what we want to see. So let's go to this documentation, container, and then we have a post, which is probably what we want. Create a new container. Yeah. So here we see that there is a lot of like things that you put, that you can put in your request to describe what kind of container you want. So you have the name, the host name, flist. Yeah, they know flist.
It's introduced, yeah.
Yeah. So so basically, which flist you want to boot from. If you have some specific processes that you need to start directly when the container is created, you can also describe them there. If you need to mount some disk directly into your container to have some persistence of your data, or for example, if you run a database and you want to have the database save on disk directly, so it's like persistent between reboots, That's how you would do it. Then you have a list of NICs. Basically, it's the network interface that you can describe. And here the documentation explain you what kind of like network you can define there, which is basically zero tier, VLAN, VXLAN, bridges if you need to communicate between containers, which is all documented, and you have the details about what you're supposed to put. Also port forwarding if you need. So I have here the create container. Oh, I just already prepared something, just again.
You're going to do basically the same thing as we did before. So it's the equivalent of what we did through the Zero-OS or the zero-core IPython client.
Exactly.
Yeah. So the same, we are using the same flist here. The flist for a plain Ubuntu.
Yeah, exactly. That's the Ubuntu one. Well, before creating it, let's try to see if there is already some containers running on there. And we see that indeed there is, because we have like a storage cluster running on this this environment. So we see that here we have some ARDB running already on this node, which are responsible for the like part of the storage cluster. So now let's try to create a new one which is running Ubuntu. You will notice here also that I described like two different NICs. The default one is basically telling, okay, give the ability of this container to reach internet. So default is basically just default network that you would expect in any container. You can get to the internet. And then I also added a zero tier. So to show you that how easy it is if you deploy containers and you have also already a zero tier network configure for, I don't know, one of your application, you need to have multiple containers reaching each other in a secure way. This is, you just need to specify which network ID that's supposed to join, and they will join it automatically. Here, this is basically the network I will join, and currently only my laptop is authorized and online on this network. Yeah, okay, so I think you're set. You can just send the request. Okay, so yeah, we had the successful response, and there it basically gives you the location inside the API where your container has been created. So if we list them again, we should now see, yeah, here our demo container which is running. So now let's see if in zero tier pop, we see it just pop up here. So I can also authorize it. Supposed to get an IP, yeah. And this is the IP. And if I try to ping it, it should work. That's not it's a physical one, sorry.
Yeah.
Why is it not giving it certificate to assign?
Refresh me.
Maybe it's just zero tier, which is. Yeah, for some reason, I don't know, zero tier doesn't want to.
Yeah.
It happens sometimes. Well, so, but then we can, of course, inspect this container. Tick, tick, tick. Get container. Let's see what I can do now. Looks basically. Yeah, that's. That's just a get. Okay, that's it.
Arne is telling me that he saw the ID.
Yep.
So it should have worked.
Yeah, I see. If we see that basically we try to inspect the full state of the container. And here, yeah, for some reason, config ECP. Yeah, I didn't get an IP. I should check why after that. I don't know. But yeah, basically we see that now the container is running. It's using the Ubuntu the FLIS that we asked. We didn't specify any port or anything, but the 0-tier is there. Yeah, so basically this is how you would start to use the Orchestrator API. I would let you like basically just read the documentation because there is a lot here, and I'm just not going to press on every button because that's a bit stupid. But yeah, you can start to really pretty nice things with that. And container, like you say, it's really easy to use. Most of our like creation requests are blocking, so for containers it's okay because it doesn't take too much time. But you could have some requests that take a bit more time. You probably see that when you deploy a storage cluster. But at least you always have the correct response. Once the API tells you that something is up and running, we have done the check behind to be sure that it's actually the case. So you don't have to do some kind of long pulling or trying to get the response again and again until something happens. So that's always pretty cool to be like just checking the response data code to have the status of your request. Well, let's just try to delete the container now to clean our system. Is it test or demo? The name is demo. So containers, delete, demo, do it. Yeah, no content, so it should be gone now. If we list it again, of course not found. Oh. If we list everything, then demo is gone. So its system has been cleaned, and yeah, back from at the beginning. Well, yeah, that's basically it. That's like it's a REST API, right? It's really not. Yeah, so basically it's the REST API. It's not rocket science, but yeah, we try to make it really user-friendly and to expose as much as basically capabilities as we can. The nice thing about the orchestrator is that all the logic that you would have to put manually by using at your service, if you would just use the Zero-core client, is that it's built in the orchestrator. So really, if you would want to start doing stuff that are self-healing and that are like monitored, and you have the status that get updated if something goes wrong, that's really how you should start working. Okay. Yeah, so I don't know if you have a question or if you have something you want to know a bit more about.
I think this is the occasion. If some of you already have questions for Christophe, go ahead.
Yeah, indeed, even from something from before or something you want clarification on.
Yeah, since Christophe is really the guy who knows it really good and really well. So if you have a very difficult question, that's your chance to ask it now.
Christophe, this is Arnie. With reference to the computer as energy, how would you measure compute usage?
How you monitor?
Yeah, measure. So that
for the power, you mean?
Yeah.
Well, we have some nice, I don't know if they've been introduced or not, but like, no, but the idea is that we have some PDU, like that's small boxes that you put between your electrical alimentation and the boxes that could monitor that for you, really at the electricity and the power consumption level. And this is also going to be monitored by at your service, and you could get graphs out of it. On the other hand, for really Zero-OS directly, Zero-OS gathers statistics of every single processes which is running on the system, which can be directly on the box, on a container or a VM. And this also, well, this monitors the CPU consumption. So you could also know what are the peaks, what application like requires the more power. If you really want to start making something green and tweak a bit your processes, that's really easy because yeah, it's really out of the box. As soon as you start a new process, you get directly the statistic from this process, and in the next release, we are working on making nice graphs using InfluxDB and Grafana for that. So you would be able to have some nice dashboards to monitor that too.
Okay, thanks.
So I'm adding PDU to the abbreviation slides. Power distribution unit. So we also have a part of our business is even creating hardware under the brand Reactivity. And Reactivity has a product with the name PDU. So power, well, it's not the name of the product, but it's a power distribution unit. So we know a lot about power management in a data center, and we can even correlate like workloads and power management. So knowing which workload in which server is consuming most of the power. Now that's a powerful insight, of course, because then you really can decide upon that information like, well, this workload, maybe we should move it from a power perspective to another node. That kind of stuff we can do. And the point we make is that we, of course, know that very well. We can integrate all that, monitor all that from within Azure Service, and within Azure Service, based on triggers, signals coming from PDUs, we can make decisions in our artificial intelligence engine, basically, what Azure Service is all about.
Mm-hmm. Yeah, exactly.
Another question, somebody? No, in that case, I'm going to take back the slides. Christophe, thank you very much. I think at least you made the people hungry about getting access to the same, exactly the same nice screens. Because what you saw in the demo is indeed the Orchestrator API console and how to interact with it, and you saw very clearly that it is much richer than what you already saw through the Python client. It's nice to interact through the Python client, but it's always nice to see a very interactive screen with documentation nicely included for you to test it. So that's what you will get once you install your own orchestrator, as we will show you in the next session. I'll also make sure that I introduce you to all the other topics that were touched a little bit, like It's Online was touched. Remember already today that It's Online, you can go to the website, it's a website.
Yeah, that's something I didn't explain, but all the APIs now are authenticated and protected using It's Online.
Yeah, so I'll put it here. It's an OAuth 02 implementation that we will certainly have to discuss as part of the sessions. And remember what I said, on top of the fact that we use zero-tier as a management network, and that of course that already is some sort of security. The next level of security is that in order to use the APIs, you need a JSON Web Token, a JWT, OAuth 02 JWT you'll get from It's Online. And we'll make sure that you understand that as part of the setup, because setting up an orchestrator requires you to set up also an It's Online organization, as you will see. We also need to introduce you later to the concept of a gateway. For those that know OpenVCloud already well today, the gateway is basically what will implement what we know today as a virtual data center, or let's say the private network that you get from a cloud space. We'll have to discuss that later. The Zero-OS storage cluster, that's basically what I showed you in the slides. That's what you need in the backend, at least for, well, at least for storing well, if you think about the Zero-OS hub that I showed you the last time, in the backend, it is using RDB and RocketDB as a storage backend. If you would want to run that on a Zero-OS cluster, you need a Zero-OS storage cluster. You also need a Zero-OS source cluster once you want to create a block storage layer on top of that for virtual machines. And that's what we will need to discuss more at length later. We also touched a little bit on RAML. I'll make sure that RAML is also better explained in the slides and in the abbreviations. RAML, I think, stands for REST API Markup Language. That's most probably what it stands for. And the nice thing about RAML is that you typically can define your REST API interface just by defining in a very human readable way and a very portable and very well understood and standardized way your API. And then we have tools like what was also introduced, GoRAML, I think was it what you said, yeah, that allows you to create a stub or
generate code.
Generate basically code and generate basically a client for interacting with that RAML API. It's very powerful. That's what we use quite often here to quickly create a fully working REST API interface. So I'll make sure that you understand, and we'll cover that again in the next session. Just for you already to know, as a preparation, if you really are interested for the next session, remember everything is in Zero-OS, GitHub Zero-OS. There we have all the repositories. The one that we will touch most of the time next week is the one with the name Zero-OS Orchestrator. Also there again, you have a docs folder. What I wanted to show you is simply that if you go to the repository, you always see the master branch. I'm already working on the documentation for Alpha 4, and so just know that you sometimes will see other documentation related to specific branch, but my documentation that I'm writing now, just remember you go to the branches. So because I'm still waiting for somebody to approve my new documentation, you go to branches, and under branches you then will see the docs update. So the most recent documentation most probably will also be found in one of the branches, and always just look for a branch like doc update. Most probably today it will disappear because it will get merged into master, but you can already look what will come next as documentation. So then you see the same structure. Here you see the slide I've been showing you. And here you see everything we will be covering as part of the next week. Most importantly, the setup. And the setup is documented here. And here you see already how it works. You typically need to have the jump scan line Docker container. And there I then say, okay, in order to install it, you need to check this documentation. Then you will need the orchestrator. Installing the orchestrator requires that you have a zero-tier network ID, you have a zero-tier token, and the token is not the same as the ID. The token is basically a token, an API token, that then can be used basically by our setup scripts to talk directly to the zero-tier API to automate stuff that you would typically do manually. For instance, like well, it's not that what we do, but well, we do it like authorizing requests to join the network and things like that. What you also see is that we introduced there for the first time ETSU online organization. As you will see well, I'm not going to show it now, but as you will see in the next session, as part of the setup, you will need to set up an ETSU online organization, and you will see how that is being used to protect all the APIs that you just saw. You also have the option to work with the domain, and of course this is important because once you start exposing APIs, once you expose RESTful APIs, even also through a portal, as was shown, of course we will not expose this through HTTP, it will be HTTPS, so you need also a certificate. Also, that is also nicely supported. And at the end of the day, the installation is simple, is as simple as what you see here. You need to specify some of these values, and you need to pass them through a script. Yeah? Now, in a way, let me say that with Christophe in the room, going forward, I don't like too much the fact that we use scripts. It's very logical that we use scripts, but clearly going forward, more and more you will do that through talking to at your service, and at your service will do actually the same thing. He will use the code that is currently in these scripts, and at your service itself will basically use then an at your service template, and this at your service template will actually include the same code. And by the way, this code of the at your service installation, sorry, of the orchestrator installation that you see here, it's all here. You can always check it. You can go to orchestrator, you can go to scripts, and there you'll see this installation script is there. So for the techies among you that really want to understand what are these guys actually doing, well, it's all open and declare. Read about it, and you will nicely understand how we do it. Because this is quite important, because once you start creating these at your service templates, that's really the very last session of this series. It's that kind of code that you will want to write. Now, furthermore, in the setup, what it discusses is that that you need to feed the at your service. You need to feed the at your service engine with all kinds of configuration data, and that's what you do through this section that I will discuss. And then and that's then a configuration file you need to specify. And this one is important also, interesting. Now that you understood a little bit from my slides how a setup looks like, what you can see here is that we are documenting all kinds of topologies. The switchless setup is typically what you will be doing when you start creating nodes in in VirtualBox, for instance. So meaning there is, remember my picture, there is no backplane. So there is no network switch to configure, and that's what we call the switchlet setup, which is also documented in a section apart. That's what we show you here. In a typical setup, you need to see the black, not the red one. In a switchless setup, well, we show two things here. Both are with a switch, but the red one shows you that you don't have a, well, no, rewind. This shows you when you have the nodes, when you really work with physical nodes, really, with physical backplanes. But there are two options here. You could work with a switch, yeah, and if you work with a switch, yeah, clearly you need to connect every node to the gigabit Ethernet switch. Remember, you might have typically two of them, one for the management network, and going forward also one for the storage network. It could be the same, typically are two different switches. Now anyhow, if you do a switchless setup, meaning even if you have the physical nodes really under your desk in your data center, you can touch them, you can still connect them together in a very connected way, which is of course much better than only have them connected to a zero-tier network. Just remember that if you really want to set up Zero-OS on, in this case, 4 physical nodes that you have available somewhere in your network, just do it like that, and it's nicely documented. We'll discuss that too. There is also one that discusses the when you really set up in a data center, and the packet.net setup is also an interesting one. Packet.net is just like OVH, but it's not just, well, it provides you like physical hardware that you can use dedicated through a cloud service, and that's packet.net. It's a well-known one. That's one we use quite often. And by the way, we also can automate that. We have in the documentation, you might remember, in Zero-OS, if you go to Zero Core and you go to booting, to the docs here, the documentation for booting, remember booting, you'll find that we also have, like we discussed OVH, we discussed VirtualBox, we discussed QEMU, Some of them we didn't discuss, and one of them was packet.net. So we also have some documentation on how to install Zero-OS on packet.net, and we also, well, here we only show you how to do it manually. I'm not going to discuss it now. We even have an at your service template that you can use and for doing it in an automated way. But that would require me to explain how these templates work. Yeah? Now, voila, we are almost there. And this documentation, that's my point I wanted to make. All this documentation is what we will discuss in the session on Monday. Yeah? On Monday, I'll learn you how to do all this. Yeah? Voila, this is about it. Thank you again, all of you, for attending the session. The session, it's a bit strange. The next session is on July the 3rd, which is already Monday. We will, as always, record the session. Most probably, I still need to decide because I need to prepare too, and I want to be sure that I'm really, really ready then. Most probably, I might decide that this session will not be in the morning, but rather in the afternoon. But then again, I repeat that always, I'm there to give you all the attention you need. If you need a private session, if you need private conversation with me, private guidance, tell me. I'm there to help you at whatever time you choose. And even if you could not attend the Monday session in the afternoon, of course, I will make sure that everything is recorded. You can watch the recording. And again, you could always have a private conversation or private session with me. That's not at all a problem. Voila. Thank you again very much, Christophe, for joining us. It was very valuable. I could never have done what you have done today. That's what we will do next week. And thank you again all for attending. If there is a question, tell it now, and otherwise I'll stop recording and give you your time back. I see one question in the group. Okay, Cara tells you, Christophe, that that she's very happy with all your help. You're welcome, Cara. Thank you very much, all. Bye bye, and talk to you soon.
Thanks.
Thank you. Bye.
Bye bye.
Ciao.
Bye, guys.
Bye.
Bye.